Here we are with number 6. Number 6 on the review says find the rational zeros and the other zeros, then factor into linear factors. So you're really doing two things here. I'm going to go ahead and put my f of x. So we're labeling it as a function. You are trying to find your zeros to this polynomial, and then you are going to list the linear factors. So you are doing two different things. Now remember, our zeros can be rational zeros and they do not travel in pairs. So when you've got a rational zero, you do not have to have its opposite. You can have irrational zeros, which typically have they do have square roots involved. Anytime that you have a square root involved, you are going to have its opposite. And the third kind of zeros that you can have are complex or imaginary zeros, and they also have to have their opposites. So we are going to first find our rational zeros. And the first thing I want you to do is I want you to make sure that every x is represented. So we start with x to the fourth, so we have 3x to the fourth, then we go down to x to the third, and then we go to x squared, and we go to x to the first. So this particular polynomial is okay because every single x is represented here with exponents. We're not skipping an exponent, because when you're skipping an exponent, you have to put that 0 in there. Now this is a 5-term polynomial. So when we get to a 5-term polynomial, we cannot factor it. We have to use synthetic division. And so I'm going to go ahead and set this up in order to do synthetic division. So I'm going to start with my coefficients. I have 3, negative 11, 15, negative 9, and positive 2. Okay? Now I'm going to start with that positive 2. That's where I look for factors. Or zeros. So I look at factors of positive 2 to help me decide what am I going to do first here. So I'm going to start with 1 because 1 is a very simple factor of 2. So I'm going to start with 1 and I'm going to see if that works. Now remember, you can look at this number at the end, this constant, and you can do positive and negatives of all the factors of 2. So we've got negative 1 times negative 2 equals 2, positive 1 times positive 2 equals 2. That's always where I would start with those factors. And so I'm doing positive 1. You could do negative 1, you could do 2, or you could do negative 2. Any of those would be reasonable places to start. So I'm starting with 1. So the first thing I do is I bring that first coefficient down. And then I have 1 times 3 is 3. Negative 11 and 3 is negative 8. 1 times negative 8 is negative 8. 15 and negative 8 combined is going to be positive 7. 1 times 7 is 7. Negative 9 and 7 together is negative 2. 1 times negative 2 is negative 2. And we end up with a remainder of 0. And because we end up with a remainder of 0, that means this positive 1 is a solution to this polynomial. And we are looking for 4 solutions. As long as we include multiplicity, this is how many we're going to get. We're going to get 4. So we're looking for 4 zeros and 4 linear factors. They can be rational, irrational, or complex, but we're looking for 4 zeros. And they might have a multiplicity. And I think this one does have a multiplicity, but we're looking for 4. So now, x minus 1 is a factor, and then the other polynomial that we're left with is 3x to the third minus 8x squared plus 7x minus 2. So what I try to do next is I try to factor this. I look and see, is there anything in these two terms that I can take out? Now I can take out an x squared from both of those, but when I do that, I'm not going to get the same binomial over here. So I'm not going to get a situation that it can be factored by grouping. So I have to go back to synthetic division. Now we've already got one of our linear factors as x minus 1, and we've got one of our zeros as 1. So again, I'm going to look at this negative 2. That's where I'm going to start with factors when I do synthetic division. So again, I usually start with the most straightforward, which is positive 1. So I'm going to write down all my coefficients and constants so that I can do synthetic division. I bring my 3 down. 1 times 3 is 3. Negative 8 and positive 3 gives me negative 5. 1 times negative 5 is negative 5. 7 and negative 5 is positive 2. 1 times 2 is 2. And again, we're in a situation where we have a remainder of 0. And it's that remainder of 0 that tells us this 1 is another factor. So we were talking about multiplicity, and that's what's happened here. We have a multiplicity of 2 right now with a 0 of 1. So that's showing up twice. So if x minus 1 is a linear factor, it is a linear factor with right now a multiplicity of 2. So that factor is showing up twice in this solution. So now I've got another trinomial that I can look at factoring. So I've got 3x squared minus 5x plus 2. So this I'm pretty sure can be factored. So what we have to do is we have to multiply our a and our 2 to get our product. So our sum and our product is what's going to drive factoring this. So 3 and 2 is 6. That's our product. We're looking for numbers multiplied together give us 6. And our sum is what's associated with that middle term. So we have negative 5. So I want 2 numbers multiplied together that give me 6 and added together give me negative 5. Now because this product is positive, that means our numbers are both going to have to be positive or they're both going to have to be negative. So here I've got negative 5. So because our product's positive, the signs on my 2 numbers have to be the same. Because my sum is negative, that means both numbers are going to have to be negative. And the net numbers I'm looking for are negative 2 and negative 3. Negative 2 plus negative 3 gives me negative 5. Negative 2 times negative 3 gives me positive 6. So here, I am going to split this. So I have 3x squared minus 3x minus 2x plus 2. Okay, so again, we're going to look at these first 2 numbers, or these first 2 terms. What can I take out of both of those? And I can take a 3 and I can take an x out of both of those. So I'm going to write it over here to the right. So I have 3x times x minus 1. Looks like we might have a multiplicity of 3 in this one. I'm going to erase some of this right here just so we have enough room to be sure we get everything. And actually, I'm just going to write that just a little bit higher so we can see it. So I'm going right up here is where I'm headed. So I have 3x times x and 3x times minus 1. And so when I multiply 3x times x, I get 3x squared. When I multiply 3x times negative 1, I get negative 3x. Now I am looking at these second 2 numbers. What can I take out of both of those? And I can take out a negative 2. So I've got a negative 2 times x gives me negative 2x, and negative 2 times negative 1 is going to give me a positive 2. So I am factoring this to 3x minus 2 and x minus 1. So when I have 3x minus 2, the zeros that is associated with this factor is positive 2 over 3, and the 0 associated with x minus 1 is positive 1. So I actually have a multiplicity of 3 when it comes to the 0, 1. So that's a multiplicity of 3. And then my fourth 0 is 2/3. So here, this is part of my answer right here, these zeros, and they are all rational zeros. I don't have any irrational or complex. Now my other factors I can write, so I've got another x minus 1. And it would be okay if I wrote 3x minus 2, but it would also be okay if I wrote x minus 2/3. Those are equivalent statements. So if you ended up writing this as one of your linear factors, that would be okay as well. So either one of those. But remember, this particular problem asked for its zeros and for its linear factors. And so that is the zeros and linear factors for this polynomial.